video, I'm going to demonstrate an integration technique from Calculus 2 called integration by parts. If we take a look at the formulas that they use, we'll take a look at an online textbook real quick. Here's Calculus 2, table of contents, integration by parts. The formula for it is shown this way. If we take a closer look at that formula, we'll try to understand its meaning. The integral of u times dv is equal to u times v minus the integral of v times du. The idea is that we may be given a problem that we can't integrate using ordinary antiderivative rules. But a formula like this might transform a problem that can't be done using simple rules into separate parts where the new integral that you get can be done using the simple antiderivative rules. Now, if we track what happens to the variables in this original problem, the u shows up as u in this part, but as du here, which is sort of like the derivative of u. And in a similar way, the dv transforms into v here and here. So the idea is that they want you to identify a part of an integral problem that you can take a derivative of. So the u part would be the part that you're taking the derivative of. And you can copy the original u to here, but you can take the derivative of u and use it here. And then for dv to turn into v here and here, you would have to understand that v would be the integral of dv, or the antiderivative of dv. So by way of example, if I was given a problem like integral of x times e to the x dx, I could see possibly the x as something like the u, and the e to the x dx as something like the dv. But it's also possible in some problems to treat e to the x as u and x dx as the dv. So how would we make a decision about that? Well, it turns out that if you take a derivative of e to the x, you get e to the x. And if you take an antiderivative of e to the x, you also get e to the x. So it doesn't get simpler, whether you treat it as the u part or the dv part. Now if we think about the x, the derivative of x would be 1, and it's getting simpler. But the antiderivative of x would be x squared over 2. That's getting more complicated. So I'm thinking it's better to treat x as the u, and that would leave e to the x dx as the dv. So my preferred way of showing that work is to write u equals x and dv equals e to the x dx, so that I can write du is equal to 1 dx, and then we would say the integral of dv is equal to the integral of e to the x. We would get v equals e to the x, and ordinarily we would say plus c, but for now we're in the middle of a much larger problem where we will add plus c at the end of that problem, so it's not necessary to add it here. And then the formula itself from integration by parts was u times v. Now for us, when you go to do u times v, the u is x and the v is e to the x. So we get x times e to the x. And then to continue the formula, we do minus the integral of v times du. So I'll have minus the integral. Now v is e to the x, and the du turns out to be 1 dx, or just dx. So what's happened is I had an integral to work out here, and I've got part of an answer minus another integral. But it turns out that we know how to do the integral of e to the x. So what we end up with is x e to the x minus, and the antiderivative of e to the x is e to the x, and then plus c. There is a technique called column integration or tabular integration, which is a shortcut for the sort of problems where you have x to the nth power times a function. I'll have to leave that for another video though, but because that one would have solved this in about 5 seconds. I hope you found that helpful. If you'd like to thank me by making a donation to my PayPal account, I've provided a link below the video in the description. If you're interested in hiring me for an appointment, or visiting my live stream where you can get help with a single problem at a time instead of hiring me for an entire hour at a time, my Twitch page is located at the link provided in the description below the video, as well as my Facebook page. Information about prices, including the amount that I charge per hour and group rates, and also the amount that I charge per problem and the live streams, is provided at those locations. To actually schedule an appointment, you can contact me directly by email. And I thank you for watching the video.